Hello everyone, happy Darwin Day. Today, we're going to talk about what evidence Charles Darwin had for his early formulation of the theory of evolution. So, let's jump right in. Charles Darwin was born February 12, 1809 in Shrewsbury, Shropshire, England. In 1825, at the age of 16, Darwin attended the University of Edinburgh Medical School in Scotland. However, he was uninterested in the lectures and was quite queasy about surgery. While there, he joined a student natural history group called the Plinian Society, helping to foster his love for the subject at an early age, and took up taxidermy. Though, Darwin neglected his medical studies, which caused his father to send him to Christ's College in Cambridge in 1828 to study theology in order to become an Anglican county parson, which is what gentlemen of his class did in those days if they didn't want to become a doctor or a lawyer or go into the military. But again, nature tugged at Darwin. He was introduced to beetle collecting and became friends with many naturalists at the college. He even wanted to study the tropics after graduation. Ironically, during his studies, Darwin became very familiar with the works of philosopher William Paley, creator of the infamous watchmaker analogy. When Darwin returned home in 1831, he found a letter from his friend and botanist John Stevens Henslow expressing that a position was available aboard the HMS Beagle, commanded by Captain Robert Fitzroy. Darwin jumped at the opportunity, and the ship set sail on December 27, 1831. Fitzroy gave Darwin geologist Charles Lyell's book, Principles of Geology, which laid out ideas on uniformitarianism. In an interesting twist of fate, Fitzroy, who was originally very interested in Lyell's ideas, became a biblical literalist years later after marrying a highly religious woman. Regardless, the first continent Darwin landed on was South America, where he made a number of geological and paleontological discoveries. We discussed his fossils in our video, An Evolving Understanding. The short version is that Darwin found fossils like the giant sloth Megatherium and the armadillo relative Glyptodon and noticed important similarities, called homologies, between them and their modern relatives. Darwin figured that modern sloths are not descended from Megatherium, or modern armadillos from Glyptodon, but both share an older common ancestor. This put in Darwin's head the idea that organisms vary through time. Later, the Beagle docked in the Galapagos archipelago, where Darwin made his famous observations on the finches, though actually tanagers, not true finches, and also tortoises. He also found marine iguanas, one of which he apparently repeatedly threw into a lagoon, but it's unlikely that this had any major effect on his early thoughts regarding evolution. He forgot to note closely at the time where the birds he mistook for separate ones lived, and regretted that later, but eventually he realized the varieties or species of finches have different morphologies based on their location and diet. He noticed a similar pattern in the Falkland Islands wara. Possibly, he reasoned, the Galapagos finches are all descended from a small group of finches that came to the islands from the mainland of South America. Therefore, organisms not only varied with time, but also distance, the foundations of biogeography. Darwin also traveled to New Zealand, Tahiti, Australia, and the Cocos Islands. The Cocos Islands were instrumental in helping Darwin to grasp how coral reefs and atolls form, as there was quite a controversy in his day. Lyell proposed that atolls, coral reefs that circle a lagoon, were the remains of volcanoes, where the coral sides were part of the remainder of the volcano's walls. Darwin wasn't impressed by this and proposed an alternative explanation, one which is still held to this day, albeit with modifications. He argued that volcanic islands would rise up, and corals would become established in their shallow waters. As the islands subsided, though interestingly plate tectonics wasn't yet known, the corals had to rise further to keep their living bits in warm, shallow water. Hence why coral at the bottom of the reef may have one type of carbonate mineral, such as aragonite or dolomite, but the upper corals may have a different one as ocean chemistry gradually changed. Darwin's voyage ended on October 2nd, 1836, where he returned a celebrity scientist. A number of the fossils he discovered were analyzed by anatomist Sir Richard Owen, who would eventually become an opponent of evolution. Darwin also learned from ornithologist John Gould that many of the birds Darwin thought were different species were in fact just varieties of finch, which was especially ironic as Gould was a creationist. It was Darwin, though, who realized the implication of this for the malleability of species. In 1839, Darwin published the journal he had taken aboard the Beagle under the title Voyage of the Beagle. His studies on coral reef formation were published in 1842 under the not-so-succinct title The Structure and Distribution of Coral Reefs, being the first part of the geology of the Voyage of the Beagle, under the command of Captain Robert Fitzroy, R.N., during the years 1832 to 1836. In some ways, this book was something of a prototype origin for Darwin, as it allowed him to explain certain natural phenomena in terms of gradual mechanistic processes. Around that time, Darwin really began to think about evolution. So, some organisms varied through time, while others, as Darwin noted in the Galapagos and Falkland Islands, varied with distance. And it was as though organisms living in particular localities were replaced over time by similar forms, called faunal succession. Darwin was, however, not the first person to notice this. Even his grandfather Erasmus Darwin had. But Charles was the first person to provide a mechanism for it: natural selection. The central idea underlying natural selection came to Darwin after reading economist Thomas Malthus's An Essay on the Principle of Population in 1838. One of Malthus's relevant points is that populations overproduce offspring, but their numbers are kept in check by the availability of resources. Finally, Darwin put the pieces together. Organisms vary over time and/or distance because more are born than can be sustained, and their particular inherent variations determine whether or not they will survive in a given environment. As many generations pass, variations gradually accumulate within populations, giving rise to new species. Though by then increasingly respected as a naturalist, Darwin still hadn't made his name with a full scientific investigation of a specific topic, the equivalent of a doctoral dissertation in what would become the way science proceeded in the decades after Darwin. So Darwin worked more on his soon-to-be theory and applied it to barnacles, animals of importance to the Navy for the damage they did to hulls, but only poorly understood. Darwin's study, which took 8 years, established that barnacles were actually highly modified crustaceans. Furthermore, he concluded that there were smooth transitions among both living and fossil members, which is precisely what would be expected if species evolved into new ones. By this time, his science friends, especially Charles Lyell, were warning him that someone else was on the trail of discovering the role of natural selection, the younger naturalist Alfred Russel Wallace, and in 1858 their warnings proved true, as Wallace sent Darwin his paper on the very subject, asking for Darwin to forward it for consideration to the even more famous Lyell. Wallace was at the time in the Far East, recovering from malaria, and Lyell helped arrange for a special joint paper to be read on their separate arguments at the Royal Society, which was barely noticed by the scientific community. Darwin was spurred by this to write a short abstract version of his unfinished natural selection book, and so in 1859, Darwin published his arguments for natural selection and against the immutability of species in his book On the Origin of Species by Means of Natural Selection, or the Preservation of Favored Races in the Struggle for Life. Don't be confused, races here isn't a reference to humans, as Darwin doesn't treat humans in Origin. He saved that argument for a later date. Darwin begins his tome with a simple comparison. Humans had been breeding animals and plants for millennia, so what if nature unconsciously did something similar? It was already understood that organisms form varieties, but at what point did a variety become a species? In essence, this is an early form of Aron-Ra's phylogeny challenge. If natural selection could craft varieties into species, could it also craft what he called organs of extreme perfection, such as the eye? Darwin argued, yes, some simple light-sensitive receptor could be honed over generations to be increasingly accurate at discerning the direction of light and objects around it. Darwin was what is now called a pan-adaptationist, meaning he thought everything was the result of natural selection. With greater understanding, we now know that this isn't the case, but the updated version of natural selection is still pivotal to evolutionary theory. Reception of the theory was, to put it mildly, mixed. Some, though still with some reservations, quickly took to the idea, such as Joseph Hooker and Thomas Henry Huxley. Lyell, who was opposed to species transmutation before origin, eventually came to accept the idea, as did the scientific community at large. A number of naturalists, like Owen and Henslow, rejected Darwin's ideas. However, theologians were also split on the issue. Younger ones tended to agree with Darwin, while older ones tended not to. This just goes to show that evolution was never in opposition to religion from the very beginning. Darwin didn't stop work, but turned to studying orchids, resulting in his 1862 book, Fertilization of Orchids, in which he explains the adaptations of orchids to certain moths as a result of natural selection. In 1868, Darwin published The Variation of Animals and Plants Under Domestication, where he attempted to explain heredity in organisms through pangenesis. As we know, inheritance isn't blended, and even Darwin gave up the idea later in life as a result of sharp criticism from engineer Fleming Jenkin. Interestingly, Darwin may have been aware of Mendel's work with pea plants, but lacking a mathematical foundation, Darwin failed to recognize the significance of what he read. Darwin even reported getting what we now call Mendelian ratios for traits during his work with primroses. Mendel, on the other hand, both read and accepted origin. If only they had the internet. It took another half-century for science to get more of the mechanisms of inheritance straight, identifying genes in the 20th century, and more decades before DNA was recognized in the 1950s. But again, Darwin's curiosity hadn't slowed down, again turning his attention elsewhere. He looked to the primates. But that's not a story I'm going to tell. Instead, I'm going to let Gutsick Gibbon tell it. Take it away.
Talk about a hard act to follow. You know, Darwin must have felt quite similarly coming off of origin and variation. The Descent of Man wouldn't see the light of day in its full form until 1871, and it was certainly a long time coming. But in what may be considered the world's first teaser trailer, Darwin hinted at what would become the Descent of Man On the Origin of Species. Light will be thrown on the origin of man and his history. The Descent of Man was originally to be a mere chapter, a short essay in variation. But Darwin would come to realize that the tale of man's place in nature would take a bit longer to tell, and so a longer tome would be required for our own story to be properly realized. The text was preceded by Man's Place in Nature by Thomas Huxley, sometimes referred to affectionately as Darwin's Bulldog, and it would tread some of the same ground by asking the same general questions. Is man apart from nature, or is he of it? To put it rather romantically, The Descent of Man is a love letter to our position in the great family tree of life. It begins with noting that humans only differ from the other animals in both body and mind by varying degree. This observation would not be fully realized until the world of genetics was open to humans decades later. It's a seemingly simple observation, one we certainly take for granted today, but at the time, this had enormous implications and did not sit well with the literalist Christians.
They're telling people we're descended from a pack of apes, even though there's nothing about it in the Bible.
You've got to take this thing with a grain of salt. I mean, come on.
But while humans from Darwin's day to our modern era still deny their humble heritage, the evidence just keeps on rolling in. Our coding base pairs match those of bonobos and common chimpanzees by nearly 99%, and our ERVs, or endogenous retroviruses, sit firmly in the same locations in our genome. Neither of us can synthesize our own vitamin C, and that flaw is mirrored in our respective genetics, continuing far back to the most basal tarsier. Our hominoid cousins can use complex lexicons and produce their own new words in sign language. They mourn their dead and long for friends they no longer see. Fiercely intelligent and emotionally complicated, they are unique animals just like we are. but we are both animals nonetheless. And our haplorine relatives reflect our own nature back at us as well. Vervet monkeys lie and steal, capuchins think up novel solutions to new problems, long-tailed macaques behave spitefully, and langurs feel sorrow. Some species show the most basal roots of our own novel abilities as well, with gelada vocal cries obeying the same linguistic laws that govern our own language. Darwin had none of this information, but he didn't need it. All it took was a dedicated investigation into the physical characteristics of the varying hominoid skeletons and brains. He saw the same type of tissue in the chimp that lurked just under his own skin. From the closed orbits to the pelvis all the way down to the feet, Darwin noted similarities. The tailbone, equally useless in man and genus Pan alike, served as a reminder that vestiges of both our pasts stuck around unless selected against or lost by a fluke of mutation. His cursory observations of baboon behavior continued to inform his thoughts. He saw them display a knack for imitation, an excellent memory, and surmised imagination may dwell in their unassuming skulls. But however impressed by the terrestrial monkeys, Darwin also placed a higher value on the mental capabilities of modern humans. No other animal, he surmised, had quite the language capabilities that man could display. As biology has progressed, we now know that communication comes in many forms, and that some of our primate relatives may have more going on than we had previously thought. In comparison of man with the other beasts, Darwin placed morality at the center of what made us so successful as social animals. A powerful ability to motivate conspecifics with emotional capital, as well as a nature more wired to cooperate, seemed to inform this idea a bit further. Finally, as a fiery abolitionist, Darwin devoted a final chapter to the perceived races of men. This chapter was rather revolutionary, as it used a biological basis to denounce the categorization of humans by race. There are, of course, some dated thoughts that linger in the pages as products of their time, but Darwin was by and large enormously progressive for the time period. The Descent of Man sold so well, a reprint was ordered within 3 weeks of publication. His daughter Henrietta is credited for much of the editing, and Huxley is given some pretty big kudos at the end of the text. Much of the controversy surrounding Darwin's work naturally came from the religious fundamentalists, who bemoaned the idea that humans, by their very nature, weren't particularly special. Man, although is well behaved, is still at best a monkey shaved. As Darwin had said himself, quote, "Man is descended from a hairy quadruped, furnished with a tail and pointed ears," unquote. This was not nearly as flattering as having descended from 2 perfect beings forged specifically by the hand of God. After the descent of man, he would hit another one out of the park with selection in relation to sex. In this text, Darwin highlighted the nature of the sexes. He posited that female choosiness drove many of the sexually dimorphic traits we see in animals like peacocks, and that the heavily competitive streak seen in some males is perhaps a consequence. There are a handful of dated ideas in these pages as well, most of which have to do with man's superiority over woman in both physical prowess and in intellectual capability. Numerous studies of human ancestors, genus Pan, specifically the bonobos, and modern human statistics have of course shown the sexes to be on par with one another as far as cognitive ability goes. Now, this idea would not have been out of the ordinary for the time, but Darwin's actions outside of this text starkly contrast with his statements within. He was shown to have greatly respected both his wife and daughters, both of which frequently helped him run through his thoughts and edit his works. He fraternized with budding female academics as well, and none spoke ill of him. His wife Emma was staunchly religious, but the two were thicker than thieves, and Darwin would continue to support his wife's Anglican endeavors well after his transition into deism and eventually agnostic atheism. And no, he did not repent on his deathbed. Thank you very much, creationists. Diagnosed with heart disease in 1882, his last words were to his family, telling Emma, quote, "I am not the least afraid of death. Remember what a good wife you have been to me, and tell all my children to remember how good they have been to me," unquote. Then, while she rested, he repeatedly told Henrietta and Francis, quote, "It's almost worthwhile to be sick to be nursed by you," unquote. It is thought that his heart troubles may have resulted from Chagas disease, contracted from the kissing bug, a hemipteran native to Argentina. Some have proposed this would have been contracted from his travels nearby, decades earlier. Such is the price for science. The legacy Charles Darwin left behind has impacted everything we know about biology and, of course, about our own origins. The previous thoughts that man belonged on some far-flung pedestal of superiority were toppled by a single observation, that life changes through time. It spoke of the impermanence of the human form and whispered of a time when men were but apes, or when apes were but shrews. The theory of evolution leveled all life to a single family tree, where superiority is in the eye of the beholder, and man is but a vapor in this constantly evolving stream of life. That man with all his noble qualities, with sympathy which feels for the most debased, with benevolence which extends not only to other men but to the humblest living creature, with his godlike intellect which has penetrated into the movements and the constitution of the solar system, with all these exalted powers, man still bears in his bodily frame the indelible stamp of his lowly origin.